Consider a reaction where 5.7 kilograms of titanium 4 chloride, so let's translate that, titanium 4, which means it has a +4 charge, and chloride, which has a -1 charge. We will flip-flop or crisscross the charges. This means I need 1 titanium, this means I need 4 chlorides. And now the charges are balanced. It reacts with, so plus, oxygen gas, which is O2 because it's a diatomic, and it will yield titanium 4 oxide, which is a little bit tricky because titanium 4 is +4, oxide is O with a -2 charge, and so you would put a 2:4 ratio, but this can actually be reduced to a +2 - 1 scenario. And so really it's going to be 1 titanium and 2 oxides. And then we'll add chlorine gas, which is a diatomic also, and so it gets a 2 as well. So now that we've balanced the charges and written the equation, we need to go ahead and balance the equation. 1 titanium, 1 titanium, 4 chlorine, 2 times 2 is 4 chlorine, 2 oxygen, 2 oxygen. I'm going to go ahead and write the molar masses of each of these compounds respectively above them. These molar masses were obtained by adding them up off of the periodic table. And that'll kind of speed up my process as I calculate. Okay, so I'm actually given the amounts of the 10,4 chloride, which is 5.7 kilograms, and the amount of oxygen is 0.8012 kilograms. And the question is, how much, well, which of the following is true? And notice that in our answer choices, we want to know how much of the chlorine is produced. So, question, kilograms of chlorine. And then, which one of these two is left over and by how much? So we'll have to determine the limiter, and then we will figure out the amount of excess from there. So in order to calculate this, I'm going to stoich both of these to chlorine to figure out how much product am I going to make and what the limiter is. So we'll start with the 10,4 chloride, 5.7 kilograms of 10,4 chloride. We're going to leave the kilo alone and just bring down grams because my final answer is supposed to be in kilograms anyway, so we'll just leave it as it is. And the mass is 189.67, and that equals 1 mole. We'll bring down moles, and now I can do the mole-to-mole ratio, which is 1 to 2. And then I can convert from moles to grams. 5.7 divided by 189.67 times 2 times 70.9 is equal to 4.261. And that's going to be kilograms of chlorine. Notice that the grams cancel, moles cancel, and I'm left with this kilo and this gram, and that's how it's kilogram at the end. Now I'm going to use 0.8012 kilograms of oxygen to find out how much product we make. So 32 grams of oxygen is equal to 1 mole of oxygen. We're going to go from moles of oxygen to moles of chlorine. It is 1 mole of oxygen to 2 moles of chlorine, and then convert chlorine to grams. 0.8012 divided by 32 times 2 times 70.9 is going to give me 3.550 kilograms of chlorine. So of these two, the smaller amount is the true theoretical yield, and the other is nothing. So this is how much of the chlorine we are going to yield, and so we used oxygen to find that amount, which makes oxygen my limiter, which means I have excess amounts of titanium 4 chloride. So now I'm going to have to stoich from the oxygen to the titanium 4 chloride, which I'll do here. Start with the amount of oxygen given. We're going to do molar-mole ratio between oxygen and titanium 4 chloride. It is a 1-to-1 ratio. And the molar mass is 189.67 grams from the periodic table. So 0.8012 divided by 32 times 189.67 gives me 4.749 kilograms of titanium 4 chloride consumed. That's how much we're going to use up of this 5.7 kilograms up here. So I'm going to take the 5.7 kilograms of titanium 4 chloride that we started with, subtract the amount that we consume, and I am left over with 0.95 kilograms of titanium 4 chloride. So these are my two final answers that are boxed, which correspond with letter A.